Good day everyone. We are the group 4 and we are assigned to discuss the topic about rainfall-runoff relation. In this topic, there are 4 subtopics. For the first topic, I will explain to you what a hydrograph is. It is a continuous record of stream flow. Hydrograph is a graph which shows the rate of flow or discharge versus time past a specific point in a river or other channel or conduit carrying flow. It can also refer to a graph showing the volume of water reaching a particular outfall. It is commonly used in the design of sewerage, more specifically, the design of surface water sewerage systems and combined sewers. Next are the factors influencing the hydrograph. First factor is the watershed characteristics, which is size, shape, slope, and storage. Second is the infiltration characteristics. Under these are soil, land use, and cover. Lastly, climatic factors, which are rainfall intensity and pattern, areal distribution, duration, and type. For example of types are rainfall and snowmelt. Next, components of a hydrograph. Rising limb. The rising limb of a hydrograph, also known as the concentration curve, indicates a sustained increase in discharge from a catchment area, usually in response to rainfall. Next, recession limb. It extends from the peak flow rate onward, the end of storm flow or the direct runoff, and the return to groundwater derived flow is often taken as the point of inflection of the recession limb. The recession limb represents the withdrawal of water from the storage built up in the basin during the earlier phases of the hydrograph. Third component is the peak discharge. It is the highest portion of the hydrograph when the rate of discharge is greatest. Fourth, discharge. The rate of flow passing a specific location in a river or other channel. Next is the lag time. It is the time interval from the center of mass of rainfall excess to the peak of the resulting hydrograph. Lastly is the time to peak, the time interval from the start of the resulting hydrograph. Barnes shown that the recession of a storage can be expressed in this formula, in which Q naught is the initial discharge and Q sub T are discharges at a time interval of days, and K is a recession constant. It can also be expressed in this formula shown, where A is equal to negative ln(k). The recession constant varies. It has 3 types. These types are based on the types of storages.
The second topic is the hydrograph separation. Hydrograph separation is considered as the first step to catchment scale water balance analysis. A wide variety of hydrograph separation methods exist, ranging from empirical to analytical and physical. Base flow separation is performed to determine the portion of the hydrograph attributable to base flow which is not associated with storm. The losing stream. Water table lower than bottom of the stream channel, and water lost as you go down to the stream. While in the gaining stream, base flow entering the stream, typical in humids, and as you move down to the stream, more water in the stream even though no tributaries exist. Methods of obtaining surface flow. The base flow is to be deducted from the total storm hydrograph to obtain the surface flow hydrograph in different methods. The first method is the straight line method. In this method, the separation of the base flow is achieved by joining with a straight line of the surface runoff to a point of the recession limb representing the end of the direct runoff. The steps are: draw a horizontal line from the start of runoff to intersection with recession limb. Then, extend from time of peak to intersect with recession limb using a lag time n, where n is equal to 0.83 times A raised to 0.2, where A is equal to drainage area in kilometers squared, and n is equal to days where point B can be located and determine the end of the direct runoff. The second method. In this method, the base flow curve existing prior to the beginning of the surface runoff is extended till it intersects the ordinate drawn at the peak. This point is joined to point B by a straight line. Segment AC and CB separate the base flow and surface runoff. This is probably the most widely used base flow separation procedure. And the last, method 3. In this method, base flow recession curve after the depletion of the flood, water is extended backwards till it intersects the ordinate at the point of inflection. Points A and F are joined by an arbitrary smooth curve. This method of base flow separation is realistic in situations where the groundwater contributions are significant and reach the stream quickly. The selection of any one of the three methods depends upon the local practice and successful predictions achieved in the past. The surface runoff hydrograph obtained after the base flow separation is also known as direct runoff hydrograph, or DRH.